This paper introduces a novel technique for incorporating dynamic response into motion capture-driven animation through the combination of a physical simulation and a specialized comparison routine, which determines the best match from a motion library following the impact. To create a response to an interaction, our system finds the clip to transition to, shown in green, based on the conditions. It then computes the in-between motion, shown in red, which is blended into the found clip following a physically based impact. Our approach is flexible enough to generate responses from a variety of interactions and results in many different types of reactions. For example, the walk-in motion is taken from a new source, with no clips remotely similar in our existing motion repository. We promote this system as an alternative to strictly ragdoll effects, like the one shown here, and we feel that it produces more compelling results. To generate a response, we first create a forward simulation, starting from the time of the initial contact. During forward simulation, the character being hit reacts in a ragdoll-like fashion. This motion is used by our search engine to find a closest matching clip in the motion library. We perform a second simulation, which uses this clip to compute desired joint angles for a torque controller. This controller allows the dynamic model to move in anticipation of the upcoming motion and reduces the differences between the simulation and motion capture postures. While we experimented with more complex transitioning approaches, a straightforward interpolation seamlessly closes the transition gap over time in a simple and visually pleasing manner. Our system automatically adjusts responses based on the configuration. For example, here we start from the same motion capture clips and simply change the facing direction of the character to be hit. The system finds small differences between the reactions of the two more forward-facing stances, but a very different reaction from the more backward-facing clips. Our technique shows noted advantage over the two-person capture shown here because we can create more severe reactions for the same scenario. We are also able to generate extreme interactions that would not be safe or desirable for actual motion capture subjects.